All right, another lesson on radical equations. And what we're going to look at in this video is a lot of context at first, just looking at some of the formulas and where they may be applied in certain situations in the world, and how we use those formulas, how we evaluate, or how we manipulate to solve for a different variable. So in this one, we're looking at, in regard to speed and skid mark, okay? So the skid mark on the road due to the tire, the friction and whatnot, the coefficient of friction, and a lot of that is tied up into where this number is coming from with that coefficient. So if I want to say that the skid mark distance is 130 feet, then it is going to be just an evaluation of 22 times 130. And you can type it in just as you see it on your calculator. You can open up your radical sign, type 22 times 130, and hit enter. And if we're rounding, we could say about 53, approximately 53 miles per hour. Because the question said, well, if the skid mark was this, then how fast was it traveling before it started to break? So we're looking at about 53 miles an hour. So we're taking what was given and we're just substituting into the radical. And that's if we're given the distance and we want to know the speed. A second example could be that what if I want to know the distance, but I'm given the speed? So let's say that, well, that was 53 miles an hour. So let's look at something that's a lot larger. So let's say that, somebody was going about 85 miles an hour and just want to see, well, how long would that skid mark be? We're saying and going 85 miles an hour before the skid mark. What would that look like? So if I want to know the distance here of that, I need to get to this variable. So what I want to do is square root I'll take the square root of both sides. So I will square this side and I will square this side. Now what we talked about in class with this is also written in a rational exponent form, would be 22 times d all to the 1/2 power. So if I'm squaring both sides, notice what that's referring back to. That's your product, your power to power rule with exponents. So when you're power to power rule, you're allowed to multiply. So 1/2 times 2 just gives this 22d to the first power, which is what I wanted. But I'm going to have to square 85, and I get 7,225. And then I'm going to divide both sides by 22 to find that distance. So I get d is equal, so approximately 328 feet of a skid mark if a car or a vehicle is going about 85 miles an hour and then before it starts braking. That's a long time. So, but that is solving for distance using this equation in regard to braking. Second equation deals with population. So if I said I have this function which models population growth, and it's growing slowly, but we're also talking about millions. So what I want to know, this p of t just represents the function we'll call p with an input of t. And notice our input here for t, and that's going to be measured in years, our time in years. And I know that how many years will it take if we're dealing to reach to 121 million. So 121 million is my goal. 88.2 million times 1 plus 1300ths t. And I want to figure out how long approximately will it take to reach that 121 million. So notice this 88 2/10 times this radical. It's multiplied. So the inverse would be to divide that. And you would divide both sides of the equation. So that goes to 1. And 121 million divided by 88 2/10 million, we're going to approximate that to about 1.37 million. And I'm still left with this radical. So remember, I want to get to this variable t. So I'm going to square both sides, because when I square a radical, that has it all go to a power of 1, but I've got to square both sides. So if I approximate 137 hundredths to the second power, I get about 1 and 88 hundredths. But I also have freed up this expression under the radical, and now I have access to this t. And then I want to subtract both sides by 1. And now I've got 88 hundredths is equal to 13 hundredths t. And then again, I want to divide both sides by 13 hundredths. So I'm going to get approximately, 88 hundredths divided by 13 hundredths is going to give me about 6.8 years approximately. 6.8 years what? Well, that's almost 7 years for a population to reach 121 million based on the equation given here. This is another formula that models wind velocity in a thunderstorm, and P representing air pressure in a unit that we call millibars, commonly used with meteorologists, and those units very specific to wind and in that field of meteorology. So again, I've got another function V, involving velocity with an input of P, and P is the pressure, that air pressure in millibars. So what's the air pressure of a thunderstorm? So I want to know what the pressure is if the velocity is 49 300 meters per second. And I want to solve for P. So it's very similar to the problem that we just looked at with the population. I need to get to the P, but it's the P variables under the radical, so I've got to kind of strip that away a section at a time. So since 5 7/10 is being multiplied, I'm going to divide. So that disappears, goes to 1. So I got 49 300 divided by 5 7/10, and I get approximately, we'll say, about 8 6500ths. So still can't get access to P without removing the radical. And again, that's going to happen as I square both sides. It's a common theme that we're seeing is squaring both sides when we're dealing with a radical with a root of 2. So that's going to give me 998 minus P is equal to approximately 8 6500 squared. We're going to get about 74, and we'll say 82 hundredths. So if I want to solve for P, and since it's negative, I think what I'm going to do is add the P variable over and subtract the 74, and that should be 82 hundredths. So I'm going to subtract the 74 and 82 hundredths from there. Kind of running out of room there. So I'm going to add the p variable. So I get p plus 74 and 82 hundredths is equal to 998. And then I'm going to subtract so I get p is equal to 998 minus 74 and 82 hundredths, and I should get about 923 and 18 hundredths, which would be millibars, which is an air pressure unit in regard to this formula where we know velocity. We're trying to figure out what the air pressure would be in millibars. It's another example involving wind speed. Beaufort wind scale is a measuring wind speed, and it has a radical in its formula. And so B representing the Beaufort number, and I would like to know what the wind speed is if I know the Beaufort number is 11. So I'm just going to substitute 11 in for B. And then progress with the solving. Now, since this is a radical expression multiplied by a number but subtracted, so what I want to do is add this number over here. That goes to 0, so I get 14 and 49 hundredths is equal to 1 and 69 hundredths times the speed plus 4 and 45 hundredths. Next, I want to divide by 1 and 69 hundredths. And that's 14 and 49 hundredths divided by 1 and 69 hundredths. And I've got about 8.6, 8 and 6/10, we'll say, approximately, times the square root of speed plus 4 and 45 hundredths. Again, common theme now, I need to remove the radical. So that's a root, understood root of 2. So I'm going to square both sides. And when I square 8 and 6/10, I get about 73 and 96 hundredths equals the speed plus 4 and 45 hundredths. Almost there. I want to solve for speed, so I'm going to subtract 4 and 45 hundredths. That goes to 0. So I'm left with speed. And so I get 69 and 51 hundredths. So this is approximately 70 miles an hour, approximately, which is a very high wind speed in regard to this wind scale. A Beaufort of about 11 is about 70 miles an hour. And we've got some practice problems here, so I'm going to go through some of these. And remember, as you're watching these videos, you can always pause it and try the work first, and then come back and watch it in segments, and or watch it all the way through. It's your choice, but if you want to have your own practice, you can pause it and then try it on your own. All right, I need to get to the x, which is under the radical, and this -6 is being multiplied, so I'm going to take the inverse and divide by -6. So this is going to give me x plus 4, and this will give me 2. And then I want to take the square root of both sides, and I get 4 is equal to x plus 4. So x will be 0. And then I just want to check back in the original. And 0 plus 4 is 4. The square root of 4 is 2. And 2 times negative 6 is negative 12. And the left side equals negative 12. So that just means that this is a correct solution. So let's look at part B. And that is the square root of x plus 3 minus 1 is equal to 7. So there's the original. So I'm going to add 1 to both sides. And I'm going to get the square root of x plus 3 is equal to 8. Again, got to get to the radical that's under the radical sign. So I'm going to square both sides. And that's going to give me x plus 3 is equal to 64. I subtract 3, and x is equal to 61. So I'm just going to go back up to the original. The square root of 61 plus 3 is the square root of 64. And the square root of 64 is 8. And 8 minus 1, I get 7. So I do get 7 equals 7. Just tells me that this is the correct solution. And then this next one, I have two radicals. So part C would be the square root of 3x plus 12 is equal to the square root of x plus 8. And I've got variables on both sides. I also have radicals on both sides. So in order to get to that, I want to square both sides. So that's going to give me 3x plus 12 equals x plus 8. Removes the radicals from both sides. So now it's just a linear equation with multiple moves. So that gives me 2x plus 12 is equal to 8. And subtract 12. And I get 2x is equal to negative 4. So that means x is equal to negative 2. So I just want to check that. 3 times negative 2 is negative 6. Negative 6 plus 12 is the square root of 6. And then negative 2 plus 8 is 6. So the square root of 6 equals the square root of 6. So C is correct. Now let's look at part E, where I've got 4 plus the square root of negative 3x plus 10 is equal to x. So in this case, I could square both sides, and that will be a little lengthy to have to multiply 4 plus the square root times 4 plus the square root again. So what I'm going to do is I'm going to subtract 4. And that's going to give me negative 3x, the square root of negative 3x plus 10 is equal to x minus 4. Again, I've got variables on both sides, but I need to remove the radical. So when I go to square both sides, I now have a quantity that's squared. And when we multiply this, because remember this is x minus 4 times x, ran out of room here. Remember that x minus 4 quantity square is x plus 4, is x minus 4 times x minus 4. So that's going to give me x squared minus 8x plus 16 is equal to negative 3x plus 10. Now when I look at this row right here of work, I see an x squared, but I don't see an x squared over here. So what I'm looking at is possible 2 solutions and a factoring opportunity. So I'm going to add the 3x over here, and I'm going to subtract the 10. So that gives me 0 on the left side. That gives me x squared minus 5x plus 6. And now I have a trinomial to factor, and I'm looking for two terms that multiply to give me 6, but add to give me 5, which would be -2 and -3. So there's no factoring by grouping because the a value was 1. So what are my solutions? Well, I have x minus 2 and x minus 3. So x would be 3 and x would be 2. So I just want to check those. I want to make sure that those work. So -3 times 2 is -6. -6 plus 10 is 4. And the square root of 4 is 2. And 2 plus 4 gives me 6. But notice that I substituted in for x was 2. So that one doesn't work. This one would be an extraneous solution. Let's try 3. -3 times 3 would be 9. Excuse me, -9. And -9 plus 10 would be 1. And the square root of 1 plus 4 is 5. And we substituted 3 here. So that means 5 is equal to 3, and that's not correct. So there's no solution. Both of these are extraneous values. So, next equation. I have x minus 6 is equal to, sorry about that. I've got x minus 6 is equal to the square root of 18 minus 3x. Again, I want to square both sides. So that's going to give me x minus 6 quantity square equal to 18 minus 3x. So this x minus 6, remember this is x minus 6 times x minus 6. So that's going to give me x squared. If I multiply all that out, I'm going to get -12x plus 36 is equal to 18 minus 3x. So again, another opportunity for factoring. I see a squared term on the left, no squared term on the right. So I'm going to just move every term to the left side so I can set it equal to 0. So everything on the right side goes to 0. This will be 18. This will be -9, and I get x squared. So again, another a is 1. So that's nice. So I'm looking for two factors that multiply to give me 18 and add to give me negative. So that means they both would be negative. So I get x minus 6 times x minus 3 is equal to 0. So x is 6 or x is 3. And I don't need to put an or in there because it could be 6, it could be 3. It could be 6 and not 3. It could be 3 and not 6, or it could not be either one of them. So we want to check that. So if I substitute a 6 back into this original, 6 minus 6 is 0. 6 times 3 is 18. 18 minus 18 is 0. Square root of 0 is 0. This one is a solution. 3. 3 minus 6 is -2. -3. 3 times 3 is 9. 18 minus 9 is 9. And the square root of 9 would be 3. This does not check. This would be an extraneous solution. And then you have your check for understanding that we looked at in class. And again, I'm going to have to square both sides. And when I square both sides, I am going to get a squared term on the left. So I get x squared equals -70 plus 17x. So I'm just going to move all my terms to the left side. So I'm going to subtract the 17x. I'm going to add the 70. And as you see, I've got an a value of 1. I need two numbers that multiply to give me 70, but add to give me negative 17. That looks like that would be negative 10 and negative 7. So x squared so that would be x minus 10 and x minus 7. So my solutions would be 10 and x equals 7. So I want to check both of those. So 17 times 10 is 170. So this, if I substitute 10 here, I get 170. Negative 70 plus 170 is 100. Square root of 100 is 10, and I substituted 10 here. So that would give me 10 equals 10. That's a solution. Let's check 7. Well, 17 times 7 is 119. And this is 119. When I take 70 from it, I get 49, and the square root of 49 is 7, and I substituted 7 in for x. So actually, both of these are solutions. Second problem, I get 3 minus 2, square root of 3 minus 2x is equal to the square root of 1 minus 3x. So, come back over here. I don't have any terms to add or subtract to either side, so we're looking at just a straight square both sides, and I get 3 minus 2x is equal to 1 minus 3x. I don't see any squared terms, so it looks like I'm going to have one solution. So I'm going to add the 3x to the left side, and I'm going to subtract the 3 to the other side. So I'm going to get 1x is equal to negative 2. And then I just want to check that. So what's negative 2 times a negative 2? That's 4. 3 plus 4 would be the square root of 7. And negative 2 times 3, negative 3 would be 6, and 1 plus 6 would be 7. So the square root of 7 is square. This would be a solution.